It's fine, thank you. Uh, Let us start the session. Okay, just give me 1 second. Okay, can anyone please confirm that my screen is visible? If the screen is visible, uh, okay, Anju, thank you so much. Okay, so this is the first week one actually of the control engineering course. Okay, so you have already, I think you have already gone through the week one. That is the video that is uploaded in the portal. Okay. So based on that lectures, we are going to the purpose of this class is that we have to solve so many questions, so that will help you to solve your assignments. Okay. So that is the purpose of this this discussion. This is I think interactive discussion should be there. You can okay. If you have any doubts regarding any questions you stock, okay. You have at any point of time, if any doubt, just raise your hand or just put a message in the chat box that to explain or anything related to anything you can just ask me. Okay. So let us start. Okay. So before starting, I just want to give this myself. What is my introduction? Okay. I am Biswajit. Okay, I am a PMRF research scholar at IIT Bombay. Okay, in the Department of Electrical Engineering. So I have already taken lots of NPTEL courses. Okay, so the control engineering is the second time I am taking this course as NPTEL tier work. Okay, so it's good time to all of you. Okay, to be here and listen. Okay, this is interactive. Okay, if you have share your knowledge, you can also share your knowledge. Okay, it's no problem. So I have already started my recordings. I'll share it on the YouTube channel. Okay, I'll mention that in the Google Sheet link. Okay, so just let me go to the first slide. Okay, so it's something that the review of week one. Okay, so what are the things that I taught in the week one lectures? Okay, you have gone through already, but I just want to give me a little bit hint that what are the topics that are covered in this. The first one is that what is a system? Okay, what is the definition of control system, and what do you mean by system in that? Okay, so how the systems are classified? Okay, systems are various types. Okay, you can classify the systems to depending on the input and the output behavior. So let me classify it because there are lots of systems are classified in the course. That is a causal system, non-causal system. Okay, like what are the linear and non-linear systems. Okay, time variant system, time invariant system, static system, and dynamic system. There are other type of systems are there like a invertible system, non-invertible system. Okay, So I'm not mentioning all. You can understand that any system, because in the real world what you are seeing, all these things can be modeled into a system. Okay, so based on the behavior of the input and behavior of the output, how the system will behave. Okay, so based on that, different types of systems are classified. Okay, I'm just giving a few examples. Okay, then after that, once the system will be defined, you have to model that system. How to model that system? You have to know the input, you have to know the output, you have to know the disturbances, you have to know the plant transfer function. So how to define that transfer function? So that transfer function you have to model. Okay, so any system, whatever the system you are surrounding, okay, so you have to make a transfer function for that. So for writing a transfer function is nothing but a mathematical equations. Okay, so how to model that plant, or how to model that system? Okay, so by using some sort of equations. Okay, there are lots of methods are there. So three methods I am just that are defined in the lecture. That is, one is differential equation model. Okay, another is transfer equation model, means you have to develop the transfer function, the relation between the input output, the relation between the input and the disturbances, the relation between anything. A system can be a single input system or a multi input system. Okay, next then another type of system modeling is the state space modeling. So where actually you are going to use transfer function approach, where you are going to use state space model. So that are the things you need to know. So whether a system depends on the time, if a system will be linear in time, then you can use transfer function equations. Then when the system means the output is dependent on time or it's independent of time, based on that the state space model are there. Okay, then any system you can classify it into different analogues. Okay, like force voltage analogy.
Alas,
uh,
someone is entering. Can you help me?
yeah, yes, yes, it's okay, fine. So now the systems I have to analogy. Okay, so let's say force voltage analogy. Okay, a system is in the force voltage analogy, how the relations will between them, a force current analogy. Okay, so all these things are already discussed in the past lectures. Okay, so you please go through the past lectures, okay, and do the assignments that I uploaded. Okay, based on the first week lectures. Okay, so I am just going through some of the questions. Okay, so we are going in detail for all the questions. I'll give you all the backgrounds of all the questions, how to solve all the questions. And I think after solving all the question, you can able to attempt the assignment. Okay, and you can upload the assignment in time. Okay, so let me go to the first question of today. Okay, okay, so on the first question, I have just classified on the week. Okay, week one, based on the how the systems. Okay, so let me define a lot say system is causal or non-causal. How you know that? Suppose a equation is given to you, and from the equation, how do you find out that the system is causal or non-causal? Okay, any system is, let me here write down. Okay,
Sir, I had a question. Can I
yeah,
ask? Sir, in real world, I am not a electrical engineer student. In
okay,
real world, what is system and modeling refers? Like it's like referring to the electrical network or uh, a transfer function means in real world how it's mimicking like.
yes,
Uh,
yes, okay, it's good question. Thank you for asking that questions. Let's say I'm just giving a practical example. Okay, uh, let's say we are all electrical engineers. Okay, now people's are everyone is moving towards the opportunity that is electric vehicle. You are going to satellite communication systems. So give an example of electric vehicle. Okay, now suppose you want to develop an electric vehicle charger. Okay, for your electric vehicle scooter or electric vehicle car. Okay, you want to develop a charger. Okay, so for developing that charger, you need to identify, okay, how a charger, how you design the charger, what are the input is required for the charger, what are the output is required for the charger. Okay, definitely the output is the battery. Okay, you want to by using this charger you want to charge the battery. Okay, what is the input you have to take in? Your input can be a AC system or DC system. Okay, input is a voltage or it can be current. So based on that input and output, now you have to design the charger. Okay, so designing the charger means what? Charger is something related power electronics things or any sort of, let's say, RLC components. Okay, some linear components are there, some non-linear components are there. Now what you have to select a topology. Let's say I'm giving example a buck converter. Okay, let me give you an example of a simple RLC network, and some networks are there RLC. Now you have to model. Okay, you have to find out the relation between your output voltage. Let's say I'm going to charge a 48-volt battery. You are somebody is want to charge a 400-volt battery. So system requirement is different. If the system requirement is different, then whatever the inside the charger, that also different. So nothing but is that this is system is defined by mathematics. Okay, you have to find out what is the output and what is your input, what is the relation between that. That is called a system. Okay, now inside the system you have to develop now based on the input and based on the output how my relation will be. You have to find some relation between the input output that is defined by the model. Okay, so now the next step is that how you modeling this. Okay, so depends on math. You have to mathematical model. Okay, you have to develop the mathematical model. Okay, once you develop the mathematical model, then you into practical you have to design the circuits, you have to implement it, you have to test it. Then the relation between input and output is satisfied. If it is not satisfied, again you have to model the circuit. These are all related to mathematics. So you just imagine that something is input and output, you have to find a relation between you. Okay, so that is just a simple example of a system, but system definition is very very complicated. Various types of system are there. Okay, it depends. So control system, how can you control system, network system, or means lots of systems are there, but how you're going to implement it, that is very broad area. Okay, so I think it's a simple answer for your questions. Okay, uh, just
Yes, sir. Thank you.
okay. Let me allow some people. Please join in time. Okay, otherwise it will. Okay, it's fine. Now let us come to the first question. Okay, now I just want to solve some of the questions. Okay, so based on the questions, you can able to solve the assignments. Okay, so let me quickly go through what do you mean by causal system and what do you mean by non-causal system. Okay, let me give an example. Okay, let it is a system. It has a output y of t. Okay, and input is x of t. Okay, input and output are I am defining with respect to time. Okay, my independent parameter is the time. Okay, I am referring everything with respect to time. Okay, so now let me define a causal system. What do you mean by a causal system? Causal system means, suppose your output, whatever the output, okay, this output, it depends on the present input or it depends on the past input. Okay, for any particular time, if your output depends on the present input or
Sir,
the past
sir, we
input.
can't we can't see the presentation. We are seeing only your screen mirroring, infinite screen mirror.
I'm sorry, my screen is not visible to you.
Sir, only screen mirroring is visible, but not your presentation. I think you are not presented.
It's okay now.
Now it is okay, sir. Thank you.
Okay, okay, okay. Let me just 1 second. If I do like that, then I am not able to write anything. 1 second. Is now the screen is visible?
Not yet, sir.
Just 1 second. Is it fine?
Yes, sir.
It's okay. Thank you. Thank you for pointing out that. Okay. So let's come back to the system what I defined. Let's say I am defining the causal system. Okay. So a system is said to be causal. Remember that if the output, you just see the output, if at any instant of time your output depends on the past input, okay, or the present input, then the system is said to be causal. If at any point of time your output y of t depends upon the future values of the input, it is called a non-causal system. So remember that it should not depends on the future. Okay, yeah, at any future instant your output should not depend. The output should depend on the past or the present input. Okay, then based on this definition, let's to solve these questions. Okay, so let me go to the first question. The first question is that y of t equal to how much? X of minus t square. Okay, now can anybody tell me that whether the system is causal or the system is non-causal? So to do that, what you need to do, you have to define some instant of time. Let's say at t equal to 1. Okay, at t equal to 1, then what will happen? At y of 1 should be x of minus 1. Okay, it means your present your output, okay, your output at t equal to 1 depends on any past instant of input. Okay, means let me give an example. This is the timeline. This is 0, this is your 1, this is your minus 1. Now you are defining at t equal to 1. At t equal to 1, this output y of t, y of 1, depends upon any past input, and past input is x of minus 1. Okay, now you can really tell that okay, the system is causal. Okay, because at any instant of time it depends upon the past input. Yes or no, the system is causal. Let's let the class to be interactive. Okay, I just don't want to be bored. When the system is causal or not,
Causal system.
it is a causal system, right? Let me give another example. Okay, let's see. You should not convince yourself by looking at the one point of time. You have to think about the broader aspect of the questions. Okay, you
Sir,
have, yeah,
I have one doubt.
yes,
The minus t square comes under is shows plus 1, no?
you have to place x of minus t square.
Okay.
Okay, in place of t you have to put 1, right? This is
Yeah.
x of minus, in place of t you have to put 1 square, right?
Okay, okay.
Now it is x of minus 1, right?
Okay, sir.
Yeah. So now you have to take another instant. Let me take another instant t equal to minus 0.5. Okay. If I take at any value which is, let's say I'm taking at this point which is minus 0.5. Okay. In this instant you find out the again the same relations. Y of minus 0.5, it should be equal to x of minus 0.5 square. Okay. Just I'm just writing for you like that. Okay. Now what is this value? This value should be x of minus 0.25. Okay, then y of minus 0.5 now becomes x of minus 0.25. Now make a number line system. Find out these 2 points. This is 0, this is minus 0.25, this is minus 0.5. You are defining your output at minus 0.5, but your output depends on the future value which is minus 0.5 is the future for minus 0.5. Okay, so that's why by looking at the system, if you take one point, you are seeing that the system, it depends on at t equal to 1, it depends on the past input. But if you take t equal to minus 0.5, it depends on minus 0.25, which is the future for minus 0.5. Okay, on the number line system, means with respect to time. Okay, this is increasing, time is increasing from left to right. Okay, from minus infinity to plus infinity. That's why for minus 0.5, minus 0.25 is the future value. That's why for one point of time it is satisfying, for other point of time it is not satisfying. So don't convince by yourself by looking at checking at one point. Okay, so you conclude that if a system at any point of time depends upon the future input, then the system is non-causal. So the answer for this question is non-causal. Are you getting my point?
Yes, sir.
Okay, now you can solve the second question. Y of t equal to cos of t. Okay, let me add someone. Okay, let's go to the second question. Let's go to the second question. Second question is y of t equal to cos of t. Okay, so let me add some space here. Okay, y of t equal to cos t. Now do the same thing and tell me the answer, whether it is causal system or whether it is non-causal system. You can define, you take a number line system, take 2-3 points, one is below 0 and one is above 0. Okay, and you do this question. What is the answer? I'm expecting some answer from you guys. Okay, nobody want to answer it. Okay, let's put a t equal to 0. Okay, if you put t equal to 0, then your y of 0 is how much?
1.
Y of 0 is 1. Okay, I think I missed out something. Okay, because there is no relation between the input and output. I'm putting here x. Okay, but x I forgot. Okay, so y of t equal to x of cos of t. Okay, this cos t is inside your function x. So now you tell me what is the answer. Y of 0 equal to, let's say I'm putting x of, if you put t equal to 0, then it's how much the value?
1.
X of 1. So y of 0 is depending on the future value of input. That's why the system is non-causal. By looking at one point, I can able to say that if my system depends on the future value, the system is non-causal. Okay, next let's go to the third question. Third question is that, okay, y of n equal to x of minus n square. Okay, y of n equal to x of minus n square. Tell me. Now I think you can able to answer it. Okay, one point I'm just
Sir,
clarifying here. Yeah,
could you present the question screen?
sorry,
Could you present the question screen?
questions in right. Okay, it's okay. It's okay. Now you just solve this question. Y of n equal to x of minus n square. Tell me the answer. And one thing I'm just clarifying that this is n I'm giving. This is a discrete system. Okay. This is not a continuous time system. N is there means a discrete system. Discrete system means you cannot take any value from, like fractional value cannot be allowed. You can only allowed integer values. Okay. Now you just answer this question. What is the answer? It's a causal system. You just put any values. Let's say I'm putting 0. Then y of 0 equal to how much? X of 0. If I put another value, let's say I'm putting x equal to 1 or n equal to 1, sorry. Then y of 1 equal to x of minus 1. Okay. It depends on the past values. Let's say I'm putting any other value. Say let's say n equal to 2. Y of 2 equal to x of minus 4. Okay. It again depends upon the past. Let's put some negative values. Okay. Minus 1. Minus 1 means you can define y of minus 1 equal to x of minus 1 is again equal to how much? Minus 1. So again it depends upon the present values. Okay. If you put equal to minus 2, then y of minus 2 is how much? X of minus 4. It again depends upon the past. So you look at all the points from around 0, you conclude that the system at any point of time depends upon the past or the present. It doesn't depend upon the future. That's why the system is causal. Okay. So don't conclude by taking one point. You take multiple points and then check it. Okay. Okay. It's fine. Let's go to the second questions. Okay. In second part of the question. Okay. Now, these questions are related to another type of system, whether the system is linear or whether the system is non-linear. Okay. So how can you define whether a system is linear or whether a system is non-linear? In control system, okay, or in signal system, we are defining linearity, okay, based on two principles, okay. So the first principle is principle of superposition. Principle of superposition. And the second principle is the principle of homogeneity, okay. Sorry. Principle of homogenization, okay, but it's called principle of homogeneity. So what are the things? You just try to understand it first, okay. Let's I'm applying the input x of t, okay. Your system is there, okay. I am defining this block as the system. Then you are getting some output y of t, okay. Input is applied, you are getting some output y of t. Let's say another person is coming and he is applying a different input. I am just allowing this different input, let's say x1t, and the same input, okay, same plant is there, and you are getting output y1t, okay. Then another person is coming, he is applying another input, okay. The same system is same, but you are getting another output y2t, okay. So there are two different inputs you are applying and you are getting two different outputs. Then another person is coming, let's say x3, okay. Then x3, what he did, he combined the first person and the second person input. So let me combine it, x1 plus x2. He applies this input to the same system, okay. If you get an output y3 based on this input x3 as y1 plus y2, okay, then if it satisfies that rule, this law is satisfied, okay, this equation is satisfied, then the superposition principle is satisfied, okay. If the superposition principle is satisfied, you don't conclude that the system is linear. You have to satisfy also the homogeneity principle. What is homogeneity principle? Let a system is there, same system is there. You are applying input x, you are getting output y. All with respect to time, I am not writing it, just understood that x is a function of time, y is a function of time. Now, what you do, you have to multiply this x with a constant, or what you are doing, you are scaling this. Okay, either you scale up or you scale down. If you apply a positive value, then you scale up. If you apply a fractional value, scale down it. If you do, you multiply a into x. If you get the same type of response, then whatever the scaling factor is there, if the same scaling factor is coming in the output y, then it is called the principle of homogeneity. Okay. If I combine these two, combine the principle of homogeneity and the principle of superposition, then how the equation will be? What you do? Whatever the first person is coming, applying an input x1t, you multiply a here. If that a is reflected in the output here, okay, then principle of homogeneity is applied here in the principle of superposition. Similarly, you combine b here. If the same b is coming here, then it is satisfying the principle of homogeneity. Then what you apply, another person, this third person, combining these two, ax1 bx2. Okay, if he gets at the output ay1 by2, then this equation is called the equation for linearity. If this equation is satisfied, then both your principle of superposition and principle of homogeneity is satisfied, and you satisfy the linearity condition. Then you can say that the system is linear or non-linear. Okay. If this concept is clear, now let us move to the first question, y equal to mx plus c. It's a very well-known equation, y equal to mx plus c. Okay, a straight line equation having an intercept c. Now, can anybody tell me by looking at y equal to mx plus c whether the system is linear or not? Because you have come across this equation from your childhood. Okay, after your 7th class or 8th class, y equal to mx plus c, whether the system is linear or not. Anybody? Can anybody tell me y equal to mx plus c is a linear or non-linear system?
Linear system, sir.
Linear, because it's a well-known equation. Tell me. I am expecting answer from everyone.
Linear.
Okay. Any other answers? There are two answers, I think. One is linear, other is non-linear. There is no other answers. Okay. Because you don't know. Because I know the answer. You also know the answer. But it is either fall on the category. It is either fall on the category of linear or it will fall on the category of non-linear. But in my institution, you are most of the people thinking that it is a non-linear system. Okay, let me prove it whether it is a linear system or non-linear system. I also don't know the answer because I don't want to memorize anything. I just want to what I discussed in the last slide. Based on the principle of superposition and homogeneity, I want to solve this question because this is the way you have to solve the question. In not only this is the method you can solve apply in a GATE exam or whatever the exams are appearing. Okay, it will not fail at all. Okay, so let me do that. So now whatever the way I told you, the same way I have defined now. X1 equal to y1. Okay, because this is my output whenever I'm applying the first input. Okay, first input is x1, then what is my equation? Y1 equal to m into x1 plus c. This is the first equation. Let's say another person is coming and he's applying another input x2, then what is my output? Y2 equal to m into x2 plus c. Okay, and another third person is coming. He told that no, I will apply a different input. I will combine this input x1 x2. Let that is defined by x3. X3 is nothing but the combination of x1 plus x2. Then what you expect at the output? Y of 2 equal to, okay, if it is satisfied the last equation, whenever you apply the input x3, your y2 becomes m into x3 plus c. Okay, but what is the value of x3? X3 is nothing but x1 plus x2 plus c. Now you simplify this equation, mx1 plus mx2 plus c. Okay, so now whenever you apply the input x3, now you got an output which is this one, y3. Okay, this is y3. Okay, this is the equation, but it has to satisfy y3, because whenever you combine the input x1 plus x2, you have to combine the output also, y1 plus y2. This y3 is now equal to y1 plus y2. It has to be satisfied. Okay, let it combine y1 plus y2. What is y1? This is your y1, this is your y2. Now you combine these two, addition. Okay, mx1 plus mx2 plus c plus another c is there. Now you see that this y, okay, whatever the y I have written here, let me change the color of the pen. Okay, now you can see this is one equation 1, this is another equation 2. Is these two equations are equal? Is this both y are equal? They are different by one c. Okay, one extra c is there. Okay, that's why it is not satisfying the homogeneity principle. It is not satisfying the superposition principle. So superposition principle violates. Okay, so it is a nonlinear system. Okay, look at here, y equal to mx plus c. This is the equation of y equal to mx. Okay, it is passing through the origin. Everyone knows that this equation is passing through the origin. It is a straight line which is passing through the origin. Okay, it is a linear system. By default, I'm damn sure it is a linear system. But if you shift this equation upward, then y equal to mx plus c is this equation having a y-intercept c. Any incremental value if add, the system is going to nonlinear. Okay, whether y equal to mx plus c or y equal to mx minus c, if any constant or any incremental system is added to your system, then that is going to be nonlinear system. Okay, so by looking at any equation, don't judge it from now. You have to solve, use of mathematical approach and solve the questions and find the correct answer. Okay, so y equal to mx plus c is a nonlinear system. Okay, now what is the second question? What was this question? The second question I have taken, let's say y of t equal to tx of t. Okay, y of t equal to tx of t. Let me create some blank papers, blank pages. Okay, okay, so another question, y of t equal to tx of t. Now please do by yourself and tell me the answer, please. Please everyone do the question and tell me the answer. Apply superposition theorem, apply principle of homogeneity, and tell me whether the system is linear or not. Just I have to add some.
Non-linear, sir.
Non-linear. Okay. Any other answer?
Linear systems.
Okay, good. There are two options. One is linear or other is non-linear. You have to check it. Okay.
It satisfies superposition and homogeneities.
Okay.
So it's a linear function.
Okay. Let me do it. Okay. Let me do it for you. Y of t equal to tx of t. Let I'm applying one input x1. Same way we have to proceed. We will not violate our principle. Okay. Let me increase the thickness of the pen. Let y1 equal to, whenever you apply the first input x1, you will get tx1t. Okay, let me write the similar way. When you applied x1, you will get y1, which is t x1 t. Okay, whenever another person is coming, he applied input x2, you will get output t x2 t. Okay, another person x3 is coming, what he did, he applied the input x3, but x3 is nothing but the combination of x1 plus x2, but he has to get an output y3, which is nothing but t into x3t. Okay, but what is the value of x3? X3 is nothing but x1 plus x2. Okay, t is nothing but x3 equal nothing but x1 plus x2. Now simplify it, tx1 plus tx2. But this equation, this is y3. This y3 has to be the addition of y1 plus y2. What is y1? tx1 plus tx2. Now you can see the principle of superposition is validated. Okay, then the system should be causal or not, it depends upon the principle of homogeneity. Now what you do, you have to apply the input. Everywhere you just applied a, here you applied a, here you apply a, here you apply b, just to write down b. Okay, here you write down a, here you write down b. Okay, now you have to get, okay, t into x3t. X3 is nothing but ax1 bx2. So here is a coming, here is b coming. Okay, now the addition is same as at, a and b. So now you can see the both the equations are same. As both the equations are same, the system is linear. Okay, I think everybody understand the procedure how I followed to solve this question. Okay, it's good if you understand, otherwise you practice by yourself. Okay, you'll get the answer.
Sir,
Yeah,
for t we have to put 1, right?
sorry.
For t we have to put 1, right, sir? For x1 it's y1. For the t implements a t x1, right, sir?
Yeah, tx1. Just I'm just taking everything with respect to time. So
Okay.
whatever x is there, if you don't confuse everything, whenever input and output I'm defining, it is always with respect to time. Okay. So if you
Okay,
write
sir.
it, it's not right. It is because I'm just solving it question, because see, well, you can write except it is because clungy. You can't because you want to compete in examination. Okay, you have how thoroughly you are thinking. One person is writing x3t, you are writing x3, so you are smarter than him. Okay, that is the way I'm just saying.
Okay.
This is the approach of simplifying the question. Okay, okay. So now if this question is clear, uh, let us uh, let us move. Another question I have, just sine x of t. Everybody please do it by yourself. Y of t equal to sine x of t. Okay. Y of t equal to sine x of t. The last bit of the linear and nonlinear system. Okay, just remember the question. I just want to create some blank page. Nonlinear, very good. It is a nonlinear system. I am not solving the question because the similar way you have to solve it. Okay. So it's a nonlinear system. Okay. If anybody got linear, then please have a raise your hand or we can clarify. Otherwise, it is a nonlinear system. Okay, let's move to the other part of the question. Okay. So the third type of question is that I am taking another type of system, whether the system is time invariant system or whether the system is time variant system. So you have come across one line, that is linear time invariant system. Linear time invariant system, linear time variant system. Okay, LTI system, everybody know LTI system, because the control system, okay, The control system is a linear time invariant system. Okay. If it is a linear time variant system, then you cannot find the relation between input and output so easily. You can find out, but you cannot find out so easily. You have to solve state space matrix. You have to go another way of approaching the question to find out the relation between
Sir,
input and output. Yeah.
the previous question seems like it's a linear system.
Which one?
Uh, yt equal to sine x of t.
It is a linear system. You got linear answer.
Could you explain me? Sir?
Okay, let me do for you. Y, it was the question like that. Y of equal to sine x of t, right?
Yes, sir.
It is like that. Y of t equal to sine of x of t. Okay. So first word, you are just apply the same way how we have solved the question. X1 equal to, if you apply input x1, you will get sine x1. Okay. If you applied
Okay.
input x2, you will get y2 equal to sine x2. Okay. Now what you do? You apply here a, you apply here a, no problem, because we both want to satisfy in one equation. You apply b here, this will be b. Okay, it should be ay1, it should be by2. Now you apply another input x3. Okay, if you apply another input x3, now x3 is nothing but the combination of first and second, so it should be ax1 plus bx2. Okay, and that gives me an output y3, which is nothing but y3 is what? Sine x3, right? What is x3? Sine x3 is nothing but this one, ax1 plus bx2, right? So this is my first equation. This should be equal to y3 is equal to ay1 plus by2. Okay, ay1 plus by2. Now what is y1? Y1 equal to, means this is a combination of these. I already multiplied there. So a sine x1 plus b sine x2. Is these two equations are equal? Sine x, sine a plus b is not equal to sine a plus sine b, right?
Okay, sir. Okay.
Okay,
Mm.
because sine a plus b equal to sine a into cos b plus cos a into sine b. Okay, that's why these two equations are not equal, so it is a non-linear system.
Okay, sir. Thank you, sir.
Okay, let's move to the another type. Another type I told you that let's go to like time invariant system and time variant system. So how to check it? Okay, so let me add someone who is waiting for a long time. This one. Okay, and how to solve this type of question? Okay, there is a simple method. What you do, you have to just check one thing. Okay, that let's say my system is there, you are applying an input x of t, let me system is there, you are getting some output y of t. Okay, next what do you do? You just delay your input. Delay means what? You just go back. Okay, I will explain you what is the meaning of delay. Okay, it's very important thing. Let's say I'm delaying my input by amount t0. Okay, to the same system, if I get the same delay in the output, so whatever the delay I have done in my input, if I got the same delay at the output, then it is called a time invariant system. Okay, it is called time invariant. Okay, what is the meaning of delay? Let's see, in an oscilloscope, whenever I'm testing in the lab, okay, what I see, suppose one pulse is coming like that. Okay, one pulse is coming, high, low, 0, 1 pulse. Okay, this is 0, this is 1, this is again 0, this is 1. Okay, now what is happening? At exactly 0, my input is going high, and exactly at this point it is coming back. Delay means what? The same system is delayed, let's say by some time delayed. Okay, from the origin, instead of starting from 0, it started an instant another 1 second. Let's say this delay is 1 second. Now after 1 second the same pulse is coming. Okay, if If the system is input like that, and you will get an output of the same type with the same delay, in the output also same delay is coming. You are delaying your input 1 second. If in output also 1 second delay is coming, then the system is time invariant system. So based on that, now I am going to solve this type of questions. Okay, so let me do the first question for you, and the second question you will do by yourself. Y of t equal to t square x of t. Now what I told you, you delay, you write down the definition. X of t minus t naught should be equal to y of t minus t naught. Okay, let's say I am choosing this t naught, this delay, let's say 2 seconds. Okay, to solve this question. Now first what you do, you delay in your input. Okay, forget about the output, you first delay in your input. Now your y of t equal how much? Delay in the input is x. Okay, so now you have to delay 2 seconds. This is the first equation. Second equation, you delay in the output. Output means output is y of t. Okay, wherever t is there, you can replace your y of t equal to t minus 2. Now you delay your output. Now whenever you delay your output, you are replacing your t to t minus 2. Now your y of t minus 2, it becomes t minus 2 whole square into x of t minus 2. Okay, this is the equation number 2. The equation 1 and 2 are not equal, so hence it is a time variant system. Got my point?
Can you repeat again?
You're not understood?
Sir, could you explain again?
Oh, 1 second. 1 second. Yeah. Let me do in a page for you. Okay. Try to understand. I have written the equation t square x of t. This is your y of t. What I am telling you, there are two things for you. You have to delay in the input. Okay. And another thing is you have to delay in your output. Okay. So first, what do you like to do? You have to delay the input signal. So you first see the equation. Is my voice is clear?
Yes, sir.
Okay, okay. So now you see, first you delay in the input. Now look at the equation and tell me where is the input is there. Input means what? Input means x. Wherever x is there, you have to delay that. Okay. So look at the question number 1. Wherever x is there, x is not there in the left hand side. X is only there on the right hand side. So you have to delay that. First to delay that, underwrite the equation. Y of t equal to t square x of t minus 2. Okay, this right hand side after delaying in the input means this is I am writing the left hand side part. Okay, let me, this is your LHS, this is your RHS. Okay, now we are writing the LHS part. LHS part means we are delaying in the input, so that is the answer is coming like that, t square x of t minus 2. Now what I'm saying, what is the right hand side is saying that you have to delay in your output. Okay, but what is my output? Output is y of t equal to t square x of t. You have to delay in the output means wherever in the output t is there, you have to replace t minus 2. So now you replace your t by t minus 2. Wherever t is there, you have to replace t minus 2. Wherever t is there, you have to replace t minus 2. Okay, now this is the delay in the output and this is the delay in the input. Is the left hand side and the right hand side are equal?
No.
No. So that's why it is a time variant system. Okay,
Okay.
let me solve for the second question for a better clarity. Okay, what is the second question? X of 2t, y of t equal to x of 2t. Okay, write down here, y of t equal to x of 2t. First you write down here, you have to delay 2 seconds or 1 second depend upon you. Let's me I am delay 1 to delay 1 second. This equation has to be validated. Means if I delay my input 1 second, my delay in the output should be 1 second. Okay, that you just remember in your mind. So what you do, first to wherever you check out where is x is there. X is there, this one. This is the x. Now you have to delay that. Don't need to delay in the output. Y of t is fixed. X of 2t. I want to delay in the input. Okay, not in the output. So x of 2t was previous. Now you have to delay it by 1 second. You got my point? This is the delay in the input. 1 second. Now what is the delay in the output? Output delay is how much? X of 2 into wherever t is there, you have to replace t minus 1. So that's why this is x of 2t minus 2. So this equation and these equations are not equal. Again, it is a time variant system. If these two equations are not equal, then it is a time variant. If these two equations are equal, then it is a time invariant system. Got my point?
Yes, sir.
Yes, sir.
Okay. So in this approach, don't confuse by yourself. You first delay the signals in the input and delay the signals in the output. Remember, delay the signals in the output means you have to change t wherever the change t is there, time is there, you have to delay every time. But delay in the input means here you can see how I delay my input. Previously it is x of 2t, I just delayed it by 1 second. X of now 2t minus 1. Okay, so like that. So in that way you have to solve. Sometimes what is happening, I'm just giving a question for homework. Okay, you can solve by yourself. If not, then let me call you, or I'll explain it. But I'm giving an example. You know differential equation d square x by dt square. Let me give you an example. Plus 5 dx by dt plus 6, okay, x equal to 0. Now tell me whether is a, because see, you know how to define linear system, you know how to define time invariant system. Now you combine these two. Okay, in any equation is given, you just combine, then you can find out whether it is a linear time invariant system or not. Because I told you, the control system is a linear time invariant system, mostly 95%. Okay, because whatever the equations you are going to solve, whatever the system you are going to solve, they're all linear time invariant system. If a linear time variant system is come which depends upon the time, then what you do, there are other methods are there to solve that. System is complicated, you are doing some assumption to solve that questions. Okay, so first you check this equation whether the system is linear time variant system or whether it is a linear time invariant system. Okay, this is a homework I am giving for you. Okay, you check it by yourself and tell me, because you have already come across these equations. Okay, a linear differential equation of second order, differential equation of third order. Okay, whether it is a linear time variant system or whether they're linear time invariant system. Okay, do some exercise by yourself. Okay, I'll tell you the answer the next class, or if it's possible, if somebody approaches this question by the end of the class, then we'll discuss at the end of the class. Okay. So after I have just classified a system based on various approaches. Okay, now coming to my first slide. Okay, in the first slide I covered these three parts. Okay, I covered causal non-causal system, I covered linear and time invariant system. Okay, static system and dynamic system. Static means, remember, static means memoryless. Okay, static means memoryless. Dynamic means there is some memory. Okay, I'm just giving an example. Let's say you have using DVD players. Okay, CD, you have a pen drive. Okay, all these systems, okay, having some memory because you are storing some files or you're storing some videos there. Okay, if that type of system is coming into your account, then these are dynamic system because they're having memory. Okay, let's say a static system, they're memoryless, that doesn't have memory. It means always the present input depends upon the present output. Okay, they don't have depend upon the past, because they depend upon the past or they depend upon the future, they have to store some memory. Okay, That's why they are static system, means your present output should depend upon your present input at that instant of time. Okay, it doesn't have a memory. Okay, so you can read by yourself, go through the lectures, and you can find out, okay, what is static and dynamic systems. Okay, now time is short for me, I have to cover these two. So let me go through the second part. Okay, mathematical system modeling. Okay, so now we are going to solve one questions. Okay, based on how a system is given to you, how you have to find out the equation for that system. Okay, after finding out the equation for the system, how you model the system. Okay, means how in the Laplace domain, how you are going to write the transfer function. Okay, so all these things now we are doing the second part of the questions. Okay, so let me go quickly to that part. Okay, okay, so this is a very common questions. Okay, because whenever people are starting control system, because I am just saying, whenever I started my control system, after seeing this figure, I told that this figure I have come across in the physics. Okay, so then I thought that there is some interesting thing, because in the physics I had just finding out the equation of the system. Okay, so how the force is varying with respect to the acceleration, how the damping force is there, how the viscous force is there, how the friction coefficient are there. So these are the things we have done in our physics. But now whenever coming to the control system, again the same thing is coming into picture. Why again the same thing is coming into picture? Because that thing which we read in our physics, now we are going to model it. We have to find out the relation between the input and what is the relation between the output. Input may be your force, input may be your force, output may be your displacement. You have to find out the relation between these two. So based on that, how you do that, let's see this type of questions. Okay, so what is there? By looking at the figure, now you can see that the question asking write the differential equation and then find the transfer function. Okay, so first look at, after looking at this question, I can how to handle this question. First you see that there are two mass. Okay, let's debug the question, how to how I'm approaching this question. You see there are two things, one is mass m1, another is mass m2. Okay, these two, see, this is mass m1, this is mass m2. Everything, remember that whenever a mass is there at the standstill position, always he wants to be remain in the standstill position. If a body is moving, he wants to move. This is based on the moment of inertia, the law of inertia. Okay, Newton's first law. Okay, so now you see, whenever a body is at the rest, he always want to be rest. Now these two masses are connected by some here you can see this part is called the dashpot. Okay, it is called a dashpot, or it is called a damper. Okay, the same thing, dashpot or damper are same thing. So what do you understand? First of all, we have find out what is the mass are there. Second thing, there is a damper is there. Then the third thing, you can see the frictional coefficient K is there. Okay, then this this B, whatever is seeing the dashpot, it store the energy in the air, or it store the energy in the form of the fluid. That's why it is called the viscous friction coefficient. Okay, viscous, something related to fluid or something related to air. Okay, now you can see this K is called the spring constant. Okay, it is related to the spring, the energy that is stored in the spring. Okay, now we can see another type of B1 is there, B2 is there, because these two masses are resting on a wheel. Okay, when you are applying some force F of t, this mass is having displaced by a distance x, and this mass is displayed by a distance x1. Okay, so this mass and m2 and m1 are rest on their wheels. So when the wheel starts rolling, there is a friction coefficient. Okay, so this b1 and b2 are called the friction coefficient. This b is called the viscous coefficient. This b1 and b2 are called the friction coefficient. Okay, this k1 is again tied to this wall. Okay, this rigid body. This is another this is called the elastic spring coefficient. Okay, so by looking at this diagram, by knowing the law of physics, I know that what are the different objects in this equation. Once you know this, okay, then just writing these equations is just a mathematical thing. Okay, You just apply the Newton's first law. Okay. If there is action, there is opposite reaction is there, Newton's third law. So just two laws will be help you to find out the equation. Okay, let me go how to do this, approach these questions. Okay, let me do one by one. So now what you do, that you have to do the free body diagram. Okay, a free body diagram of mass m2. Let's say why I'm doing for the first m2, because the force is applied on m2 only. Okay, let me make that body, m2 is there. When m2 is there, one person among you, let's pull the mass in the right hand side by applying an external force F of t. F of t is the right hand side force. But this mass always try to remain in the standstill position. So there is some force is applied because of the moment of inertia. This moment of inertia, because that force is called, let's say this is called Fm. This is nothing but mass into acceleration. Let's say m2, acceleration is x because displacement is x, so acceleration is d square x by dt square. This is the first force I am saying, because this force is applied on the body m2. That's why there is a force Fm which is act in the opposite direction of this force, that is called Fm. Okay, so one force is now acting in the left hand side. Now you see on the, what are the other things. Okay, the other thing that is connected to this body is this B. Okay, so because of this B, okay, is connected between the mass m1 and m2, whenever this body is displaced in the right hand side by x, this B also displaces some distance. What is that distance? Because as it is connected in both the bodies, and both the bodies having a displacement x and x1, this B, this force, because of this B, there is a force that is called the viscous force that is acting in the opposite direction again, Fb. This Fb is defined by how much? What is that value of Fb? Anybody?
X minus x1.
B into x minus x1, right? But you have to multiply that constant, right? But here you have to write down dx by dt. Okay, B into d by dt of x minus x1. This is the viscous force. Similarly, this spring constant k is also associated k. This spring also connected between m1 and m2. So what is the spring force that is applied in the backward direction? Another force is applied in the left hand side. Let's say spring. This will be k times of x minus x1. These are the three forces. Apart from these three forces, any other force can you find out?
B2.
Okay. What is B2? It is a
Damper.
damper. Okay, damping force. Okay, so that should be again B2 times of dx by dt. Okay, I am just writing d by dt of again x1 or x minus x1. It's only x,
Just
right? X,
x.
right, right. So these are all the forces that is acting on the mass m2. But there is a right hand force f of t, and all the forces are acting in the left hand side. Okay, now you just balance it. Left hand side force equal to right hand side force. Okay, I am just writing here m2 d square x by dt square. I am just writing double dot. Double dot means d square, second order derivative. Again I am writing b2. Okay, let's b into x dot minus x1 dot. Okay, similarly b2 is there, x dot plus another k is there, x minus x. This is the first equation. Similarly, do the free body diagram of mass m1 and find out. Now let me do here m1. M1 is right there. M1 is here. Now tell me, what is the force, right hand side force on m1? What is the right hand
B.
side?
damper B.
No. External B. These are all the forces we are acting in the left hand side. Okay. But
Okay.
what is the right hand side force? External force. Is there any external force in M1? No. F of T
Okay.
equal to 0. There is no external force. Because of this, M1 is connected to M2. As M2 is displaced by F of T, M1 is also displaced, but there is no external force. Okay. Now, because as it is displaced by some distance x1, but there is opposite force because of its rest of inertia, moment of inertia. So that force is m1 into d square x1 by dt square. This is the force is applying in the negative direction. Okay, because of this displacement x1. Now, what are the things that is connected to m1? You find out. There is a spring is connected on the left hand side k1. Because of this k1, there is a force, opposing force in this direction, that is find out k1 times of x1. And because of this right hand, B and K are connected, so there is some force is connected in the left hand side, is B times of x1 dot minus x dot. Another force is there because this K is connected between M1 and M2, so you can write K times of x1 minus x. Another force also there because of this B1. Okay, so you can write B1. Okay, and this should be only x1, so x1 dot. Okay, so these are the different forces. Let me circle it. These are the different forces which are acting, okay, on the body m1. Clear? These are the 5 forces which are, okay, applying on the body m1 in the negative direction, but on the positive direction the force is 0. Now you have to equate. Once you equate, you will get another equation. So there are two equation 1 and equation 2. Okay, you got my point?
Yes, sir.
Okay, so this is the way you have to solve the question of the damper equation. Okay, now let me quickly go to another question. Okay, first try to solve this question. This is similar type of question, but how you have to going to approach it, that I want to know. Okay, see, there is a external force on the body M. This is the body M. External force is the F of T. Okay, here nothing is given, so damping force B1 equal to 0. Okay, here K2 is given, some displacement x1, and there is no dashboard is there, or there is no damper is there, so B also 0. So there obviously there is no damping force. Okay, now only the spring force is there, and whenever the external force is applied, because of moment of inertia, there is a force is there. So now just tell me what is the first equation. Just write down the free body diagram of the mass m. The right hand side force is F of T. This is displaced by amount x. So opposite force is m into x double dot. Okay, d square x by dt square, right? Because of this spring K2, because this spring also K2 is connected, and it is also displaced by x1. Okay, so in this type of question, see, previous question there are two mass and both the masses are displaced by a distance x and x1. But here you can see only one mass is there and one force is there. X is displaced, there is a displacement of the body M by a distance x. But here there is no body is there, but it is displacement showing on the question by x1. So in that case, if you are a good thinker or a good learner, then what you do? You assume that there is a mass is there. Okay, assume that this mass is 0. Simple thing. M equal to 0. Now you draw the free body diagram. Here you assume that there is a mass which is displaced by x1, and what is the mass value? This mass m equal to 0. Okay, that's it. Solve the question now. It is very easy for you. Okay, assume this mass m equal to 0. Now this is the first equation, first opposing force. What is the second opposing force? Second opposing force is K2. So K2 times of x minus x1. Damping force is 0. So these are the two equations. F of T equal to mx double dot plus k2 x minus x1. Okay, this is the first equation. What is the second equation? For the second equation, you have to draw the free body diagram of mass m0, which is not existing. Okay, first draw that. This m equal to 0. Okay, here one spring is connected, k2, and another spring is connected on the left hand side, k1. Okay, this is a rigid body. Damping force is not there. External force also 0. F of t also 0. F of t 0, mass is 0. Okay, so because of this x1, there is a force, but as the mass we are assuming that it's a virtual, so m into d square x1 by dt square is equal to 0 because m is 0. That's why this force also 0. So what is this force that is existing? Only the spring force exists. One force in this direction, okay, x1 displacement, another force k2 which is in between x1 and x. So write the second equation directly, k1 x1 plus k2 x1 minus x equal to 0. So these are the two equations. You need to solve it and find out the transfer function. You got my point how I am approaching this question?
Yes, sir.
That's okay. So, so this is the way you have to approach the questions whenever a damper and mass body is there. Okay, these are the easiest question. I am saying that these are the very easiest question. Don't be looking at this question. People are getting, oh, what is the question is coming from physics. Okay, I am a control engineer. Why I should solve this question? Because these are the easiest question. You get definitely good marks, and that's just a balancing. Just see the mass, see the free body diagram, how many forces are there on the mass, find out all the force, make it all the force equal to 0, input force equal to output force. Okay, that's it. Okay, if that question is okay, now you come to this question. This is the last question from the system modeling. By looking at the question, can you tell me what is the equivalent spring constant?
K1 K2 by K1 plus K2.
Okay, good. K1 into K2 divided by K1 plus K2. Any other answers? Any other answer? How many of you actually watch already the lectures and appearing this tutorial? Okay, you have not watched, that is also fine, but I am suggesting that you have to watch. Otherwise, I am just covering a 70 to 80% because the stipulated time of 2 hours, because the lecture is around every week there are 10 hours lectures, but this class is around 2 hours. So try to watch the lectures and come to. Okay, so this one person said that, okay, this k1, because he is seeing that these two k1 k2 are connected to a rigid body. Let me like that, I just draw the, okay, let me connect this k1 is a spring, another k2 is a spring, it is connected to a rigid body. Let's say rigid body is ground. Okay, is connected, and here I am asking the force. Okay, and he thought that these two k1 and k2 are parallel. That's why calculated the equivalent resistance, which is k1 k2 divided by k1 plus k2. But this is the force in the force analogy system. Okay, but what you did, you are going into the voltage analysis system or current analysis system. Okay, so already if you watch the video, then you have to see the force voltage analogy. What is the force voltage analogy? In the force voltage analogy, force is a replacement of a voltage. Wherever voltage is there, you have to replace that voltage by a force. or wherever force you are applying, replace that by a voltage source. Okay, how in the force there is a mass is there, because you saw in the damper there is a mass. This mass is replaced in the voltage analogy by a L. Okay, L is called the inductor or inductance. So mass is replaced by your inductance. Okay, and damper B, damper is a frictional force. It is always opposing force, because friction resistance is there. That's why it is replaced by your resistance. As mass is some storing energy is there, it is replaced by inductor. Okay, but this spring, okay, is replaced by a capacitance, equivalent capacitance 1 by C. Okay, the spring is somewhere related to capacitance. That's why assume that whenever you find springs, you assume that these are capacitors. Okay, so now you can see the two capacitors are connected in what? Parallel. What is the equivalent capacitance? If you're not comfortable in force analogy, you have to convert into a voltage analogy. In voltage analogy, you see that's to this is a capacitance. It's a capacitance, then two capacitances are connected in a parallel, so it should be C1 plus C2. Okay, so answer should be K1 plus K2. It means the idea is that you have to remember all these things. You remember that whenever a spring is there, you assume that in your mind it is some sort of capacitance. Okay, so assume that now two springs are there, so it should be connected in parallel. So the equivalent spring constant is the addition of these two, K1 plus K2. So don't confuse, because many people will be confused on this question. So but it's a very simple questions, but you know the logic, what is the logic behind that. Okay, okay, let me go to the okay, the previous question. I already find out the equation. Now it is your task by yourself to find out the transfer function. Okay, so let me go to write the equations. Okay, what are the equations I have written? The first equation is this one, m into, okay, mx double dot plus k2. The first equation is m x double dot plus k2 x minus x1 equal to 0. Okay, equal to f of t, sorry. Convert into Laplace domain. Okay, in the Laplace domain this should be s square. Okay, what is the Laplace domain? D square x by dt square replaced by anybody?
S square.
S square plus k2. This is simple x. Okay, there no dot is there, so this is simple x minus x1. This will be f of s. Okay, this is equation 1. Similarly, solve the second equation and find out the relation between x of s divided by f of s. You have two equations you can solve. Okay, put one equation in other and find out the relation between these two. The simple question, I don't want to solve by myself, you just do. Okay, okay, let's come to another question. This is another important question. This is the third part. You can say that when now you come to electrical circuit, because you are very familiar with the electrical topology, electrical circuits. Now, if electrical circuit is given in terms of R, L, C, next you have to find out what is the relation between, okay, what is the relation between the input and the output. Okay, now this is a another model of the transfer function. Let me see how to solve this question. So here what is, first try to understand the question. He is saying that you are applying some input at the input in terms of voltage V of t. Okay, now he has given some current I1t is flowing here, some I22 current is flowing, and there is an inductor L is there, and the voltage across the inductor is given by VLT. Okay, now you have to find out the equation which models the voltage across the inductor. So you have to find out the voltage across the inductor, okay, in terms of input, in terms of other parameters in the circuit. So how to do that? You have to, everyone how the Kirchhoff's voltage law, Kirchhoff's current law. Okay, so what this is, the current is flowing I1t. Okay, so and here in the second I2t is flowing. Let me what you do, let me change the color. Okay, okay, here this current I1t is flowing in this loop. Okay, let me assume this current is in this direction. This I2 is flowing in the second loop. Okay, in this direction, like that I2 is flowing. Now in the first loop, write the KVL equation. In the first loop, write the KVL equation. Can anybody tell me what is the KVL equation in the first loop? I am starting at this point. Okay, always my reference, I am always choosing the reference of the negative point. Let's say I am starting with this point. I am moving from left to upward. Okay, I'll take the negative sign. This is my assumption. Minus, if I am moving from minus to plus, you have to take minus. This is my assumption. Okay, now write down minus V of t. This is the second. This current is flowing in this resistor. Remember that whenever a passive element current is flowing, this is always positive sign, this is negative sign, because current will flow from positive to negative in any passive element like RLC. Okay, now the current direction polarity is like that. As you are choosing the first point, then you have to choose the first point here. The first point here is positive, so put a positive sign. What is the voltage equation? I1 into R1. Similarly, in this equation, whenever this current is flowing here, again from top to bottom, okay, when the top to bottom current is flowing, but here two currents is flowing. One current I1 is flowing from top to bottom, and other I2 is current is flowing from bottom to top. So in this resistor R2, the equivalent current is I1 minus I2. So write down that plus, because I am taking this sign, okay, first sign, plus how much? R2 times of I1 minus I2. Okay, again, whenever you are moving here, again the capacitor, you see the plus sign is given in the question, plus this one, so I'm writing plus VCT. Okay, so write down plus VCT equal to 0. This is the first equation in the first loop. Everyone is clear?
Yes, sir.
Now write down the second equation in the second loop. Okay, second loop KVL equation. What is that one? You can start at any point of time. I'm just removing this one for the simplicity. Okay, now these are the two equations are flowing. You start from here because I am interested from VL. Okay, so write down, you are moving from top to bottom because the current direction is giving like that. Whenever the current from the passive element, it is flowing from top to bottom, the plus terminal is like that. Okay, because as the plus terminal in the question it is giving the same way, so we have taken plus VLT. So plus VLT. Okay, now you reach at this point, you again move in this point. Now you can see here, you are to move in this direction to complete the loop, right? But in this loop, the current is flowing here, but here we have to take the negative sign, because our assumption that whenever we are moving in the loop, we have to always take the first point. The first point is positive, so I have take positive here. Then here, whenever I'm moving in the up, the first point is negative, that's to write down minus VCT. Again, you have to, whenever the current is flowing in this resistor R2 in the upward direction, always remember that whenever in a passive element current is flowing from positive to negative, this has to be positive negative, because the current has to always flow from positive to negative. Okay, so now write down what is the equation there, plus R2 into I2 minus I1, this equal to 0. This is equation number 1, this is equation number 2. Any doubt? Any doubt to anybody how I written these two equations? Okay, no doubt, very good. Now, but as you know that this 1 and 2 is there, now you have to find out the voltage across the inductor. Okay. Now solve these two equations and find out the relation between VLS divided by input V of S. Okay. This is a homework for you. Do the Laplace transformation of the equation 1 and equation 2. Okay. And find out the relation between the output voltage VLT whenever we are applying an input voltage V of t. Okay, can you do it by yourself? Nobody is responding in the problem or what? Is I'm audible or I'm not audible?
You're audible, sir.
You're audible. Okay, I am audible. So you are listening to me. So you can solve by yourself and find out the relation between the output and the input. Okay. So these are the questions I prepared. I have touched all the parts from the first lecture. Okay. So force voltage analogy, force current analogy. Okay. Uh, so the first part of the system I already completed. Okay. The second part of the equation that so the state space model will read later. Okay, because this is a system which is very complicated, which a time variant system. Will read whenever time variant system, then we'll come to state space model, how the state space model are defined. Okay, transfer equation model, because any LTI system can be replaced by a transfer function model. Okay, so these are all the things we have already covered it. Now one final thing I just want to quickly tell you, that the force voltage analogy and the force current analogy, these are the two things. Remember that in the, let's see, in my examination when I am giving the exam, I forgot that whether mass is replaced by inductor or my force is replaced by a voltage, I don't know. Okay, let me forget it. Then how you derive it? Okay, just remember that in a force voltage analogy, let me define. A mass is there. Okay, it is tied to a rigid body through a spring constant K. Okay, this is a rigid body, this is also a rigid body. There are some wheels are there. Okay, some frictional force is there because of these wheels, and when I'm applying a force F of t, there is a displacement x. Okay, for this simple equation, the F of t, if you write the F of t, then this F of t is nothing but mass into d square x by dt square. Okay, plus because of this friction force B, there is a b dx by dt plus kx. This is a very common equation. We have already read it from the physics. Okay, this is a very popular equation for a free body diagram. When a mass is connected to a rigid body and is applied some force and it is rolling on a surface having frictional coefficient b. Okay, now as you know this equation, I don't remember this equation. I am now deriving the equation in front of you because I know that this system is like that. Now let's say in the force voltage analogy, they want to relate between what is the replacement of this mass, what is the replacement of this b, what is the replacement of this k. Okay, what to do? First, what you do, you have to in your mind, what you create a RLC circuit. Okay, RL and C network. Okay, there is some voltage is applied, R is there, L is there, and C is there. So write the equation, write a simple KVL. What is the simple KVL? V equal to, I am writing, the current is flowing I, so V equal to IR plus L di by dt plus 1 by C into I dt. This is a very general popular equation from the network theory. Okay, so once you know, find out the Laplace transformation quickly. V of S equal to I of S into R plus L times of S into I of S. Okay, then I of S divided by C of S. Okay, quickly what you do, okay, you have to compare this equation 1 and compare this equation 2. Now you can see where is dx by dt? Okay, if you want to do the Laplace transform from equation 1 also fine, otherwise you compare these two equations, equation 1 and equation 2. Okay, this is the equation in the force analogy, this is the equation in the voltage analogy, 1 and 2, just to compare 1 and 2, just to compare the order, different order of derivative. Okay, so once you do that, then you can find out the relation between what is the voltage is replaced by which quantity, the resistance is replaced by which quantity. Okay, then you can get the easy answer for that. Okay, otherwise the best way, what you do, you have to make the Laplace transformation, and you have to see that check the coefficient of s. What is the coefficient of s here? What is the coefficient of I of s, or what is the coefficient of s square? What is the coefficient, like that you have to check and you can find out. Similarly, the another thing, that suppose force current analogy will be there. What you do, force analogy, you know, force analogy will never change, this is the equation for that. But if you ask in place of voltage analogy, what is the equivalent term in the current analogy, then don't do a series RLC circuit, you just do a parallel RLC circuit. Okay, this is the R, this is the L, and this is the C. Okay, here is some potential V is there. Okay, apply a KCL, here some current is flowing I R, here is some current is flowing IL, and here is some current is flowing IC. So sum of all the current equal to 0 at that node. Okay, so if you do this equation and solve the Laplace transformation and you equate to the equation 1, you will get the relation between the force and current analogy. So don't remember by heart. Okay, so do this exercise. Okay, and you can easily relate between the force voltage analogy and the force current analogy. Okay, so got my point. So I'm stopping the class here. Okay, the next class will go to in details of the week 2. Okay, so in week 2 you have to please come up with preparation, and by leaving this today, actually just I'm giving one hint that if you solve your question assignment 1, okay, if you are facing any problem in the assignment while solving, I'll just give a hint, I cannot help you to solve the questions. If you require any help, okay, then you can contact me in this number. Okay, okay, or you can mail me. Okay, you can mail me. Okay, and this I'm just giving my mail ID. Okay, you can mail me on this email ID at the date iitbombay.ac.in. Okay, so either you can contact me or you can email me. I'll definitely help you to answer all the question or anything related to your subject or anything related to technical things. I can help you during the course time. Okay, so thank you so much everyone for attending and listening to me. We'll meet in the next week. Okay,
Thank you so much.
Thank you, sir.
thank you all of you.
Thank you, sir.
You're welcome.
Thank you, sir.
Welcome to all of you. So